Hi everyone, welcome back. If you want to support me with what I'm doing, please just press like and subscribe. That'd be really helpful. Fundamental Theorem of Calculus. Oh, there's so much I can explain in my head. There's a turmoil between explaining too much, not explaining enough. So I am defaulting a lot of the times unless I make more videos. Just I want to keep the videos short. More videos, maybe split it and do another video later on the more details. At the moment, this one here, I'm going to have a look at it. I'm actually, again, torn. I'm going to go right through it properly and show you a little bit what it is. We're talking about getting the derivative of an integral. Basically, the fundamental theorem of calculus is talking about a derivative will undo an integral, or an integral will undo a derivative. So just like we say the opposite of left is right, up is down, the opposite of -3 is +3, the opposite of, oh, we're talking about dog and cat, but no, we won't go there. So they're opposites of each other. Another good one is the opposite of square is square root, and the opposite of cubed is cube root. So they're the opposites of each other. So we're expecting them to cancel each other out, and that we're just going to end up with a 4x plus 7. Now people get confused with the t and the x. Look what we're going to do. We're going to get this integral using the letter t, but we're going to replace it. We're going to substitute an x. So all of these t's are going to turn into the letter x. And the reason we're doing that is so then we can differentiate it using the letter x. So we're integrating with the letter t, substituting an x, so I can differentiate with an x. So if I did the whole process and I didn't know that the fundamental theorem of calculus did what it does, and I didn't understand it, I can just write down this and I can go, well, I know how to do an integral. So the integral is going to be, integrate 4t will be 2t squared. Integrate 7 will become 7t, and then we add a constant. But when we're substituting values, I don't have to add a constant. So then we're going to substitute 10 and substitute x. So now I've got the derivative of, and I do all this substitution. Let's see what happens. This is where I'm talking about the t's will turn into x's. So I replace the t by an x. I've got 2x squared plus 7x minus, replace the t's by the 10. And I've got 2, and I'm going to shortcut it a little bit. 10 squared times 2 is 200. And 7 times 10 is 70. And I went a bit crazy with those numbers on purpose to make them stand out a little bit. So now I've got the derivative of, and if I kept that square bracket there, remember the order for brackets is inside we'll do these parentheses, which these days we call brackets. And these ones here are actually traditionally the real brackets, what we do actually call brackets. These days people call them all brackets. So now I've got a 2x squared and I've got a 7x and I've got minus 270. Pretty crazy number, but I like it. Now we're going to differentiate that using the letter x, which is why we have to replace the t's by x's. So when I differentiate that, I end up with 2 2's are 4 with an x, and I end up with the 7x just becomes a 7. And what happens to this? It becomes nothing, it becomes 0. So the constant will drop out. So it doesn't matter what number I use here, which becomes that number there, which affects all of this here. This number here, the constant, actually completely drops out. So I could have used the number 20 there, or 2, or 0, or minus 50. Any number I want, I can put in there, and it drops out. And if you have a look, I've gone from 4t plus 7 to 4x plus 7. So the nice thing with a fundamental theorem of calculus, I can just replace that t by the x. Then what happens though, let's go without going through this whole process, I'm not going to on this video. The derivative will undo the integral, so I know that I'm going to turn the t into an x. So I can go straight to the answer and I can go, well, that's x squared. I've replaced the t by the x minus 3. But there's a problem. These are upside down. And if you understand about doing integrals from other videos, that the integrals go, you substitute this one first. So for example, this one here, I would have substituted 20 there, and I would have gone subtract all of these. So if you have a look at it, instead of putting x squared minus 3, it's really, we're talking about the negative of that. So this has reversed what these were here. And I could go right through the question, but again, I think it'll make the video too long. Almost tempted to do it though, and say cut it out and just do the video properly with that in. So maybe as a rule, if you look at it, you can just go, I'm going to replace a derivative undoes an integral, and you're going to replace the t by the x. The 5's irrelevant, that's going to all drop out. So we've got an x squared minus 3, but when they're turned upside down, it becomes a negative of the answer. And then the big one. Now, there is discussion about whether this can be in the actual exams in Western Australia. I have talked to people, one person in charge, and they said there's a possibility. So it's been a couple of years since I've asked that, so I don't know if there's been any clarification. What's the beauty of the Fundamental Theorem of Calculus, which we often refer to as FTC, Fundamental Theorem of Calculus? So the derivative is going to undo the integral. That means I'm going to replace every t here by the x, but it's not just an x, it's more complicated. So I'm going to write this down again, and I'm going to say that's 10 minus, and I'm going to put brackets there, so I'm going to replace the t by the 2x cubed. And that's your Fundamental Theorem of Calculus. Says that that's the answer to the question. The 0 is irrelevant. It wouldn't matter if I had 5 or 6 or 10 or minus 50 there. But this is more complicated. Now, I can go through examples with my class the other day. I went through examples and explained why this is more complicated and made the case. Not for here. Just going to show you what the rule is. So, all the time I have this arrow. I say this is what people forget. Or I say don't forget, because I see so many students forget. Don't forget, it's more complicated. How much more complicated? It's that much more complicated. But here's the weird part. It's the derivative of that. And we can prove it, but I'm not going to go there now. The derivative of 2x cubed is 3 2's are 6. And then the 3 becomes a 2. And we've got 6x squared. And so from the Fundamental Theorem of Calculus, you write the same thing. Substitute that into there. But then remember to differentiate the inside, which is 6x squared. So really the answer is just 6x squared. Square root of 10 minus, and I could write that like that, or if I wanted to, then I should go a step further and go, well, that's 10 minus 2 squared is 4, and then you've got the x cubed. When you square it, is x to the power of 6. Will it turn up in the WACE exams? I think I'm sceptical that it will ever turn up, but it could. It'd be interesting if ever I was a person writing the WACE exam. We call them WACE exams here in Western Australia, but the Year 12 final exams at the end of our schooling. Yeah, I'd think about it, but even if I was on the person, one of the people writing the exam, the other people might say, no, we don't want to do it. Interesting to see what happens. I hope it's helpful. If you're enjoying it, please let your friends know. Thank you.